Don't be afraid of projectiles unless they're heading towards you, obviously. Many students find the idea of dealing with parabolic flight paths troublesome, but I'm going to show you how to break projectile motion down into two simple components and solve any A-level problem on this topic. I'm going to look at what is projectile motion, breaking down motion into two components, the key equations, a step-by-step example, and 5 top tips for solving projectile motion. So what is projectile motion? It's simply the motion of an object that is thrown or propelled into the air and is influenced only by gravity in its initial velocity. Think of a ball being kicked, a cannonball being fired, or even a basketball being shot into a hoop. Here's a key point. In projectile motion at A-level, we assume air resistance is negligible. So the only force acting on the object is gravity. This causes the object to move in a parabolic trajectory. Without air resistance, the path of an object rising and falling to the same height will appear symmetrical. To understand why, let's break down the motion into two components. This should be your first step before you attempt any maths. The two components are horizontal motion. Without air resistance, there are no forces acting horizontally. There is therefore no acceleration and the velocity remains constant. The mass for this component is simple. Vertical motion. This is where things get interesting. The object accelerates downward due to gravity, which we call acceleration due to gravity, little g, which is typically around 9.81 meters per second squared. It is the vertical motion that dictates the time of flight and how far the projectile will travel in the horizontal direction. Let's look at an example. An object is launched at 30 degrees to the horizontal at a velocity of 50 meters per second. It doesn't matter where the object is launched from, be it the ground, the top of a cliff, or even a hot air balloon. We will follow the exact same steps. We draw a right-angled triangle. You could even draw it to scale if you wanted. I haven't. You see that the hypotenuse makes an angle of 30 degrees to the horizontal and has a length of 50 meters per second. We can now use trigonometry to find the horizontal and vertical components of the velocity. The horizontal component is 50 cos 30 degrees, which is 43.3 meters per second. The vertical component is 50 sine 30 degrees, which is 25 meters per second. This is the hard part done. You now have the two components of the velocity, and you can treat those like any other linear velocity. Practice doing this with different problems and you will soon have projectiles mastered. Let's now look at the equations that you will apply to these two components. Hopefully you are familiar with the Suvat equations. That's the equations that apply to motion with a constant acceleration. As we have already said, the only force affecting the projectile motion is gravity, and so the only acceleration to consider is the constant little g, downwards. The first thing that I like to find out is the time of the flight. To do that, we need to consider the vertical component of the flight. A good starting point could be the equation A equals delta V over delta t, or V minus U over t. You know that the acceleration is little g. You also know that when the projectile reaches its maximum height, the velocity is momentarily 0. Therefore, g equals 0 minus u over t, and t is just minus u over minus 9.81. which is u over 9.81. Use your value for your initial velocity in the vertical direction for u, and you have the time to reach the maximum height. You'll notice the negative sign. I've assumed that going up is in the positive direction, which makes the initial velocity positive. Gravity is working downwards, and so is negative. Do keep an eye on your signs. Pick a convention and stick to it. Now that you have the time to reach the maximum altitude, you can work out the maximum height of the projectile using s equals ut add half at squared, or v squared equals u squared add 2as. This should give you everything that you need to solve any problems about vertical motion. The horizontal motion is much simpler because it's constant, and that's because there's no acceleration. You have calculated the time from the vertical component and now simply need to use the familiar term v equals s over t to calculate the distance. Let's solve an actual problem to see if this makes sense. A ball is kicked from the ground at an angle of 30 degrees with an initial speed of 20 meters per second. Find the time of flight, the maximum height reached and the range of the projectile. Step 1. Let's break the initial velocity into its horizontal and vertical components. From this triangle, you can see that the horizontal velocity is 20 cos 30 degrees, which equals 17.32 meters per second. The vertical velocity is 20 sine 30 degrees, which equals 10 meters per second. The time to maximum altitude is t equals u over 9.81, which gives us 1.019 seconds. The total flight time up and down is therefore double this at 2.04 seconds. The maximum height reached can be found using s equals ut add half at squared, which equals 10 times 1.019 add 9.81 times 1.019 squared over 2, which equals 10.19 add 5.093, which equals 15.3 meters. The range is found by considering the horizontal component and the time of flight. S equals Vt, which equals 17.32 times 2.038, which equals 35.3 meters. Before I give you 5 top tips for dealing with projectiles, let me just point out that there are some free-to-download questions and answers to accompany this video on my website. There's a link in the description. Also, do take a moment to like, subscribe and even comment if you've found this useful. It's only with this support that I'll be able to continue to produce more free resources, and so I'll be very grateful. Anyway, here are my top tips for mastering projectile motion problems. Always resolve the initial velocity into horizontal and vertical components first. Use separate equations for horizontal and vertical motion. Don't mix them up. When calculating maximum height, remember the vertical velocity is 0 at the peak. Double check your units and be consistent. Meters, seconds, you know the score. Choose a sign convention for negative and positive and then stick to it. Above all else, practice, practice and practice. This is the best way to get comfortable with the equations.